I'm Steve with FRSR, and I want to talk to you about how we do our stamped concrete. Everything starts with site preparation. So first thing we do is we come out and we set forms according to the design. We either paint it in the ground or generally we do a sketch and we build to that sketch. We set the forms at least a day in advance so you have a chance to look at the shape, make sure it's exactly what you want. The next step is compaction. So we use a jumping jack to achieve our compaction, and that's about a 250-pound machine that looks like a foot, and it bounces and it compacts the ground. That is the most effective way of getting full compaction. If we ever need backfill, we bring in road base, which is a structural fill. It's designed to have zero expansive properties, so you don't have to worry about expansion, and it achieves 100% compaction. The next important thing is our reinforcing schedule, and that's very important with concrete. What we do is we use a grid of rebar on 2-foot center, so 2 feet going in each direction. Another thing that we do that's really important is kind of the traditional way of setting that steel is to lift it into the wet concrete, and the idea is that concrete gets underneath it and holds it in place. We found that that doesn't really work. So what we do is we actually put a rebar chair underneath the concrete, and that holds it into the center of the slab where that reinforcement is actually going to do you some good. If it floats down to the bottom of the concrete, it's really not doing any good sitting between the concrete and the ground. So that's a really important thing to make sure you have a structurally sound slab. The next extremely important thing, of course, is the concrete mix. At FRSR, we have a specially designed mix that we've been working on for several years, and we tweak it every time new products come out. If we've ever had a problem, any excuse we have to modify that or understand and really dial in a perfect mix, we take advantage of. Right now we're using a 4,000 psi straight cement mix. You can substitute fly ash for a certain percentage of the cement and still get a compressive strength, but we think that the stickiness of the concrete, the way it bonds to each other, is much stronger using straight cement. We put some additives in that. First we put in a mid-range water reducer, and what that does is it requires less water in the mix to make it fluid. So it basically densifies the concrete. You also end up with a stronger concrete because as the water evaporates out and dissipates, it leaves void. And that's generally what causes shrinkage cracking. So like on a hot day, you have straight water mix. As that concrete evaporates, it creates shrinkage, and the shrinkage has to manifest itself someplace, and it does that by cracking. The other thing we do is we put a product called micromesh in the concrete. Micromesh is basically the next generation of fiber mesh. Fiber mesh is little polypropylene fibers, almost like fiberglass, that gets mixed throughout the mix, and you can always tell fiber mesh concrete because it looks kind of hairy. Micromesh is actually a soluble fiber that gets mixed in the same way that fiber mesh does. It mixes throughout the mix, and that creates quite a bit of tensile strength. So the concrete does have a little bit of flexibility relative to concrete, of course. And we found that this concrete design that we're using, the rebar schedule that we're using, on proper compaction, and the other key component is cutting your control joints. Control joints have to be cut in the right place, at the right depth, at the right time. If you're very careful about all these things, you can have concrete that may at some point develop a hairline crack, but for the most part, you're not going to get any major cracking. We really take these extra steps because we want a slab that's going to last you 25, 30 years.